Questions 11 through 20 on the 2019 Grade 12 AMC 12B. How many unordered pairs of edges of a given cube determine a plane? Let's talk about it with a diagram, of course, and let's label this. We're labeling the edges 1, 2, 3, and 4. Those are the top edges. Let's label the bottom edges 5, 6, 7, and 8. And then now let's label the side edges. So 9, 10 over here, 11 over here, and 12 out here. Okay, so each edge can be paired with another edge to form a plane. And my question is, how many? So let's say I started with 1. 1 can be paired with what edge to form a plane? Well, it can be paired with 2. It can be paired with 4. It can be paired with 3. So 3, 4, put it in order here. And I believe if you stick to the order, 6, 8, 9, and 12. So let's talk about this now as to why these are planes. Okay, 1 and 2, as you can see, that forms a plane. 1 and 3, those are parallel, they're part of a plane. 1 and 4, again, they're part of a plane. And 1 and 6, that would be, where's 6 here? Those are parallel, so that would be part of a plane. They're just on different levels, but they're part of the same plane. 1 and 8, well, 1 and 8 is pretty obvious that it's part of that plane. And then 1 and 9, well, of course, those are going to make a plane. And 1 and 12, those make a plane. So I hope that is convincing. I know that's a little bit abstract. I actually had to wrestle with this one a little bit. So basically, this is 7 right here. So each of those 12 edges can be paired with 7 to form a plane. So there's 12 to choose from the first edge, like I did there. And then each of them can be combined with 7 others. So the answer is 84. But that's not one of the answer choices. And that's a good thing, because you might circle it and move on. The reason is because we've double counted. Because if, for example, if you made this list for 2 as the first choice, you would find that one of them is 2, 1. So as you can see, 2, 1 and 1, 2 are the same. So because I've double counted, I've got to divide 84 by 2, and when I do, I get 42. So the answer to number 11 is D. Right triangle ACD with right angle at C is constructed outward on the hypotenuse AC of isosceles right triangle ABC with length 1, as shown, so that the two triangles have equal perimeters. What is the sine of 2 times the angle BAD? Well, we can easily figure out CA. CA squared is going to be 1 squared plus 1 squared, so CA is root 2. Right there. And then, since this is an isosceles triangle, this is 45 degrees right there. And then now we are going to have to do some labeling because we're not given anything about CD and DA. So I'll just call this A and I'll call this B. Well, we know that from Pythagoras, A squared plus root 2 squared is equal to B squared. So that gives me that 2 is equal to B squared minus A squared. And I can factor this B minus A and B plus A. And then they also tell me, though, the two triangles have equal perimeter. So the first triangle has a perimeter of 2 plus root 2, this one right here. And the second triangle, I guess based on my lettering, the perimeter would be A plus B plus root 2. So that means that 2 is equal to A plus B. Okay. So I can substitute that in there. So that means 2 is equal to B minus A times 2. So that means B minus A is equal to 1. So B is equal to 1 plus A. So let's put that here, 1 plus A. Okay, that allows me, I believe, to figure out the values of A and B. I can substitute them back into here, I guess. Why make it more complicated? So I have a plus b. B is 1 plus a. So that means 2a is equal to 1. A is equal to a half. So this is a half, and therefore b is obviously going to be 3 over 2. Okay, so I think I'm ready now to figure out this big long. I'm anticipating a trigonometric identity because we've got this 2 in there. Okay, not a problem. Let's tackle this now. So we have the sine of 2 times these angles. So the first one is 45, and the second one I don't know, so I'll just call it theta for now. So it's 2 times BAD, which is 45 plus theta. Okay, so now we have to put in that big long identity, right? And you guys remember this. It's 2 sine, in this case, 45 plus theta, and cos 45 plus theta. All right, now we've got to expand this. So 2 times sine 45 plus theta. So that is going to be the sine of 45 times the cos of theta plus the cos of 45 times the sine of theta. And then we've got to multiply this by this guy, cos of 45 plus the cos of 45 plus theta, like that. So that is going to be the cos of 45 times the cos of theta, and then minus sine of 45 times the sine of theta. Okay. All right, so we've got some progress here. Let's put it out here. So 2 sine of 45, well, now we just plug in the numbers. That's 1 over root 2. So cos of theta, well, that's where you use the triangle now. Since we have the dimensions, we can use those to figure out the cos of theta. And I'll just put the cos of theta out here just so we can plug them in pretty quickly. Cos of theta is going to be root 2 over 3 over 2, which is going to be the same as root 2 over 2 root 2 over 3, and I'll put in the sine of theta. Sine of theta is going to be a half over 3 over 2, and that is 1/3. Okay, so that makes it a little bit quicker. So here we go. So we have a cos theta, which is 2 root 2 over 3, then cos of 45, 1 over root 2, and then the sine of theta, which is 1/3. And then the other one, cos of 45, 1 over root 2, cos of theta, 2 root 2 over 3, minus the sine of 45, 1 over root 2 times the sine of theta, which is 1/3. So this becomes 2 2/3 plus 1 over 3 root 2 times 2/3 minus 1 over 3 root 2. Okay. So if we expand that, we get 4 over 9. The second and third terms cancel, and then 1 over 9 times 2, which is 18. So multiply top and bottom by 2 to get a common denominator. We get 8 minus 1 over 18. And that is 2 times 7, 14 over 18, which is 7 over 9. 7 over 9 is the answer. So that would be choice D for number 12. A red ball and a green ball are randomly and independently tossed into bins numbered with the positive integers, so that for each ball, the probability that it is tossed into bin K is 2 to the minus K for K equals 1, 2, 3, ... What is the probability that the red ball is tossed into a higher numbered bin than the green ball? All right, so we have some bins here, and I'll just draw the first few, and they're labeled. So this is K equals 1, K equals 2, and so on, K equals 3, K equals 4, and it just keeps on going, right? And we have two balls. We have a red and a green. And the probability that it goes into each of these is given by this formula, 2 over minus k. So in this case, the probability would be 1 over 2. Here it would be 1 over 4. Here the probability would be 1 over 8, 1 over 16, and so on, right? Just dot, 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 just keeps on going like that. So we want the red ball to be placed in a higher numbered bin than the green ball. Okay, so what I'll do is I'll make a little table, and let's talk about this. So we have green, red, and the probability. So the placement of the green ball, then the red ball, and then the probability. Well, if the green ball is placed into the bin that's called k equals 1, the first one, then the red ball can go into any of the other ones. So any of the other ones except k equals 1. Because remember, we want the red ball to be put in a higher numbered bin than the green ball. Okay, so what's the probability, first of all, that the green ball goes into k equals 1? Well, that's a half. So it's a half. And then we have to multiply that by the probability that the red goes into any one except the k equals 1. Well, that's just going to be 1 minus a half. We can put it in any one of these, but it can't go in here. So the total probability is 1, so we just have to subtract that guy. Okay, so that looks like 1/2 times a half, which is a quarter. All right, let's keep going here. So I think I will do, I'll do 4. I think that should be good enough to see the pattern. Okay, k equals 2. If we want the rule to hold, r can go into any except it can't go into k equals 1 or k equals 2. So the probability that we put g into k equals 2 is a quarter. So that goes here. And then multiply this by all of these, which would be 1 minus this and this. So 1 minus a half minus a quarter. And that, I believe, is a quarter. So this is going to be a quarter times a quarter, which is 1 over 16. All right, let's keep going. K equals 3. Again, it can be in any except k equals 1, 2, or 3 in order for this rule to hold, that the red ball is tossed into a higher numbered bin than green ball. Okay, probability that g goes into k equals 3 is 1/8. So that goes there. And then the probability that r goes into any except 1, 2, 3. So 1 minus these 3. So 1 minus a half minus a quarter minus 1/8. And that number here is 1/8 when you do those fractions. So it's 1/8 times 1/8, and that is 1 over 64. Okay, some of you probably have the pattern figured out, but in case you don't, we'll just do one more. If it goes into k equals 4, the green one, then r has to go into any, but it cannot go into k equals 1, 2, 3, or 4. All right, so that means probability that g goes into k equals 4 is 1 over 16. And then again, we have to multiply by 1 minus a half minus a quarter minus 1/8 minus a 16th. And that is 1 over 16, this whole thing, when you do the math. So it's 1 over 16 times 1 over 16, which is 1 over 256. Okay, so I think you get the point here. The probabilities, you have to add them all up, right? And it just keeps on going forever. So the total probability is going to be a quarter plus 1/16 plus 1 over 64 plus 1 over 256, and then it just keeps on going. So this is what is known as an infinite geometric series. And the good news is that there's a formula for that. A over 1 minus r, where a is the first term and r is the common ratio. So in this question, what is the first term and what is the common ratio? So that means my total probability. The first term is a quarter, so that's A. Common ratio you can get by taking the second term and dividing by the first term. And when you do that, you get a quarter. So the common ratio is a quarter. All right, so this looks like a quarter over 3 over 4. Invert and multiply, and you get 4 over 3, and that is just 1 over 3. So the answer to this question, number 17, is C. Let S be the set of all positive integer divisors of 100,000. How many numbers are the product of two distinct elements of S? Well, 100,000, as I'm sure you know, is 10 to the power of 5. And you can break down that 5 into 2 times, you can break down that 10 into 2 times 5, and therefore it becomes 2 to the power of 5 times 5 to the power of 5. So if we take any number that is a divisor, it would be of the form 2 to the power of A times 5 to the power of B, where A is anywhere between 0 and 5, and B is between 0 and 5. These would be the divisors, any number of that form, where A is between 0 and 5 and B is between 0 and 5. Okay, so we take two distinct of those elements. So if I take two distinct, it would be, the first one I'll call it A1 times 5 to the B1. And then I'm taking a product, so it would be, the next one would be distinct, so it's going to be another A1 and A2. So let's just say 2A2 times 5B2, like that. Now if you combine these, it'll be 2A1 plus A2 as the power times 5B1 plus B2. And A1 plus A2, if you look at this right here, the minimum it could be is 0, and the maximum it could be is 10, right? And same thing with B1 plus B2, the minimum and maximum are 0 and 10. So the number of possible values for A1, A2 look like 11, 0, 1, 2, all the way up to 10. So we have 11 possible values for this. And the number of possible values for B1, B2 are also 11, 0, 1, 2, 3, all the way up until 10. So the number of possible values would be 11 times 11, which is 121. And that is one of the answers. But AMC always likes to, be a little tricky. There's always, not always, but sometimes there's some overcounting, inadmissible values, things like that. And in this case, there's 4 values that are inadmissible. And therefore, you'd have to subtract those 4, and that would bring you to 117. But let me explain what those 4 are. The key word in this question is distinct. And there's 4 times where you don't get distinct. And those are as follows. The first is when A1 plus A2 is 0, and B1 plus B2 is also 0. If that is the case, you would basically get 2 to the power of 0 times 5 to the power of 0, which is basically 1 times 1. 1 and 1 are not distinct. You have to have 2 different terms. And since 1 and 1 are the same term, that is inadmissible. The other scenario is when you have 0 and 10. This becomes just 2 to the power of 0. This is 5 to the power of 10, which is going to be just 5 to the power of 10, right? But how did you get 5 to the power of 10? You can't get that with one term because B can only go up to 5. So you must have done a 5 to the power of 5 times a 5 to the power of 5. That's the only way you could have gotten 5 to the power of 10. But if you did, you have 2 of the same elements. So again, for the same reason, inadmissible. Another inadmissible is the 10, 0. Very similar reasoning. Here we have 2 to the 10, 5 to the 0. Well, 5 to the 0 is just 1, so that's just 2 to the 10. How did you get 2 to the 10? It'd be 2 to the power of 5 times 2 to the power of 5. These are the same. They have to be distinct. And the last one is when you have 10 and 10. So 10 and 10 is basically 2 to the power of 10 times 5 to the power of 10. Now, the only way that could have happened is if you had 2 to the power of 5 times 2 to the power of 5 times 5 to the power of 5 times 5 to the power of 5. And one combination of this would be combining this with that. So it would be 10 to the power of 5 times 10 to the power of 5. And again, those are the same. They are not distinct. So these 4, 1, 2, 3, 4 scenarios have to be subtracted from the 121, and when you do, you get 117. So number 19, the answer is C. As shown in the figure, line segment AD is trisected by points B and C so that AB is equal to BC is equal to CD equals 2. 3 semicircles of radius 1, AEB, BFC, and GCD, those arcs, have their diameters on AD, lie in the same half plane determined by line AD, and are tangent to line EG at E, F, and G respectively. A circle of radius 2 has its center at F, the area of the region inside the circle but outside the 3 semicircles shaded in the figure can be expressed in the form A over B pi minus root C plus D. What is A plus B plus C plus D? A few very helpful lines I will draw. The first one is right across like that. The next one is right down like this. And the third line is on the other side like that. Now, we have to figure out this area. I won't shade it in. I'll just write a perimeter around it like that. That is what we have to figure out. So how do we do that? I'm going to break it up into 3 sections. The first section is this top, which is essentially a semicircle. The next section is that bottom. And the final section are these areas right here. If I can figure out the area of those 3 sections, I will have solved the question. So let's first just figure out the top one. That one right there. That is probably the easiest one. I'll just write top here because that's just a semicircle. So it's pi r squared divided by 2. And r is 2 since that is the radius of the big circle. So that's just going to be pi 2 squared over 2, and that is just 2 pi. So I can just put that in there, 2 pi right there. Okay, the next one is going to be the sections right here. These ones in the middle, like that. Those ones I can figure out fairly easily. How though? Well, take this full rectangle and then subtract from it 1, 2, 3, and 4 quarter circles. So that would be able to figure out that shaded region. Okay, so that, whatever you want to call it, we'll just call it middle. It's going to be the area of that rectangle. This is 1 and this is 1, 1, 1, 1. So 1 times 4 is the area of that rectangle. And then we want to subtract from it 4 quarter circles. 4 quarter circles. So 4 times pi r squared divided by 4, which essentially is just 1 full circle. So this is really just 4 minus pi r squared. And r, in the case of those smaller circles, is just 1. So this is just 4 minus pi. right, so I got that. Now the final segment is this segment right here. That one I think poses the biggest challenge, but it's not so bad. I'm going to draw some lines now. One that goes straight down, and then one that goes from F to that point right there. And I'm going to label this. So this is 1. This from here to here is the radius of the large circle, so that's 2. And this is a right angle. So as you can clearly see, you can use Pythagoras to figure out that length very quickly. It would be root 3 from here to here. So that means this is a 30, 60, 90 triangle. And this is obviously 90 degrees. So therefore this is the 60 right here, 60 degrees right there. So to figure out the area of this section, which would be half of what we want, it would basically be the area of that pi segment minus this triangle. So I'll just call this right here, whatever you want to call it, let's just call it A. So A would essentially be the pi minus the triangle. So the pi is 60 degrees, very important because it gives me how much of the circle, 60 over 360, namely, of the area of the circle, which is pi r squared, and r is 2. And then that triangle is easy, 1/2 base times height. The base is root 3, the height is 1. So this looks like 4 pi over 6 minus root 3 over 2. And of course, this whole thing is not A, it's 2A, because A just represented half of it. So now I have to get 2A. So 2A would basically be 4 pi over 3 minus root 3. Okay, so now we're done. We can now figure out the total area of the shaded region. That total area is going to be this 2 pi plus this 4 minus pi and this 4 pi over 3 minus root 3, like that. And when you add up all these guys, 2 pi plus 4 minus pi plus 4 pi over 3 minus root 3, you get 7 pi over 3 minus root 3 plus 4. And that is of this form. As you can clearly see, it is in that form a over b pi minus root c plus d. So that means that my a is equal to 7, my b is equal to 3, my c is 3, and my d is 4. And they want me to find a plus b plus d plus c. So just add up those guys, and when you do, you get 17. 17 is the answer to this excellent question. Number 20, the answer is E. Lily pads numbered from 0 to 11 lie in a row on a pond. Fiona the frog sits on pad 0. A morsel of food sits on pad 10. And predators sit on pads 3 and 6. At each unit of time, the frog jumps either to the next higher numbered pad or to the pad after that, each with probability 1/2, independently from previous jumps. What is the probability that Fiona skips over pads 3 and 6 and lands on pad 10? We are starting at pad 0, and from there we can go to pad either 1 or 2. So far we are fine. From pad 1 we can go to either pad 2 or 3. So 3 is no good, so I'm going to circle the ones that are good, because 3 has a predator. Okay, so from 2 we can move forward. We can go either to pad 3 or 4. 4 is where we want to be. We don't want to be on 3. From 4 we can go to either pad 5 or 6. 6 is no good because that has a predator. Then from pad 5 we can go to either 6 or 7. 6 is no good. 7 is where we want to be. From pad 7 we can go to 8 or 9. Both of those are perfectly fine. From pad 8 we can go to 9 or 10. If we get to 10, we win. So that's when the game ends. If we get to 9, we have to keep going. We either go to pad 10 or 11, and we want to go to 10. So let's circle all the ones that are good. From 9 this way, we go to either 10 or 11. And that means 10 is the one where we want to be. Okay, so I hope that made sense. Let's calculate the probabilities. Each of these has a probability of a half, right? So 1, 2, 3, 4, 5, 6, 7, 8. To get to there, it would be a half to the exponent 8. So this probability is 1 over 2 to the 8th to get to this 10 right here. How about let's get to this 10? Well, 1, 2, 3, 4, 5, 6, 7 this time. So a half to the exponent 7. So that is 1 over 2 to the power of 7. How about this 10 here? To get to there, 1, 2, 3, 4, 5, 6, 7. So it's 7 again. So 1 over 2 to the power of 7. Okay, so now that you get the hang of this, we'll do the next part, where the first jump was to 2. 2 is perfectly fine. Now we get to either 3 or 4. 3 has a predator, so we go to 4. That's the only one we should choose. From 4, we can go to 5 or 6. 6 has a predator, so we choose 5. 5, we can go to 6 or 7. We choose 7. From 7, we can go to either 8 or 9. Both of those are perfectly fine. From 8, you can go to 9 or 10. 10, you win. From 9, you had to keep going, either 10 or 11. And this one, you win. From 9, this 9, you can go to either 10 or 11. And here you win. Okay, so now let's figure out the probabilities of these guys. To get to this 10 right here, 1, 2, 3, 4, 5, 6, 7. So again, we have a 1 half to the power of 7. So 1 over 2 to the power of 7. To get to this 10, let's see here, it's going to be 1, 2, 3, 4, 5, 6 this time. So 1 over 2 to the power of 6. 1, 2, 3, 4, 5, 6 to get to that 10. And that is, again, 1 over 2 to the power of 6. So now we have to add these guys. So that's going to be 1 over 2 to the power of 8, which is what? Let's just get a common denominator first. So 1 over 2 to the power of 8 plus 3 of those 1 over 2 to the power of 7s plus 2 over 1 over 2 to the power of 6. So common denominator obviously is 2 to the power of 8. So that's just 1. And then we'd have to multiply top and bottom here by 2. So that's going to be 3 times 2, which is 6. And we're going to have to multiply top and bottom here by 4. And that's going to be 2 times 8, which is 8. 2 times 4, which is 8. So that's going to be, what, 15. And 2 to the power of 8 is 256. So 15 over 256. And therefore, number 16, the answer is 8. How many non-zero complex numbers z have the property that 0, z, and z to the power of 3, when represented by points in the complex plane, are the 3 distinct vertices? Complex numbers. Okay, so if the vertices form an equilateral triangle, then that means that we've got some sort of a scenario that looks something like this. I'm not entirely sure how it looks, but it's an equilateral triangle. And therefore, this can be z and this can be z to the power of 3. So that means the distance from here to here equals the distance from there to there equals the distance from there to there. It's equilateral. Okay. Well, where do we proceed from here? Obviously, they're complex numbers, so we're going to have to use some sort of a format, either polar form or the trigonometry form. I think I'll go with the trigonometry form, although there's nothing wrong with using the polar form, whatever you're most comfortable with. We all know that z is equal to cos theta plus I sine theta, and they abbreviate this as just cis theta. So that means that z to the power of 3 is going to be cos of 3 theta plus I of sine 3 theta, right? That's using de Moivre's theorem. Now, none of that helps us in an interesting way. The only thing that's going to really help is a diagram. And let's just give some very, very basic here's z, and let's say here is z to the power of 3. So if I draw a line from the origin to z, the same length has got to be from the origin to z to the power of 3, like that. So now here's the heart of the question. To go from z to the power of 3, because it's equilateral, that is 60 degrees. So if we make that rotation in terms of our format here, we write it like this: z times the cis of 60 would result in z to the power of 3. That is pretty much the heart of the question it's going to help you solve. Okay, if you're convinced of this, let's keep going. So what is cis of 60? Well, it's this stuff right here. It's the cos of 60 plus I sine of 60. And that's going to be z to the power of 2, right? Because z third divided by z, if you put the z's on one side. So where do we go from here? Well, there's a very helpful rule, I write it up here, that if you have z to the power of n and it's equal to r cis theta, then z would be the root of r, the nth root, times cis of theta over n. Now, in our case, I didn't put r, right? Because r was just going to be 1. But if you're not convinced that it's 1, let me explain. It's equilateral, so the distance from 0 to z has to be the same as the distance from 0 to z to the power of 3. And the only way that's possible is if both of those have the same magnitude, and that is that the magnitude of z is 1. So that's why I didn't put in the r. R is basically just 1 in this case. So here it simplifies to just cis theta over n for z to the power of n, or just z, I should say. Now in our case, our theta is 60 and our n is 2, because we are basically trying to figure out what is z to the power of 2 when theta is 60. So it's cis 60, like that. And we can put the 1 in for r if you really want to. So that means z would be the root of 1 times cis of 60 over 2. Since our r is 1 and our theta is 60. So this is going to be plus or minus, since the root of 1 is either plus or minus 1, cis of 30. So there we go. That is our big long formula. So plus or minus cis 30. So that would give me either cis is going to be 30, right? The theta value, I should say. So that gives me cos of 30 plus I sine 30, or minus cos of 30 minus I sine of 30. Okay, so that gives me two values. But there's another way to draw the z to the power of 3. It can be 60 degrees in the other direction, like that. So it could go this way also. So this would be z to the power of 3 here, where this is 60. That angle from there to there. And when you do that, you get the following rotation. You would get z this times negative 60, because the formula is basically for counterclockwise rotation. So if you're going clockwise, you've got to put negative there, and that is equal to z3. So if you take z and you rotate in the opposite direction 60 degrees, you get z to the power of 3. So this gives me minus 60. Cis of that is z squared, and again, as before, it's going to lead to z is this time equal to plus or minus the cis of negative 30. and that's going to be either cos of minus 30 plus I sine of minus 30, or z will be equal to minus cos of minus 30 plus I minus I sine of minus 30. And there we go, we got another 2. And these are distinct. You can figure them out using your brain or your calculator to see that they are indeed 4 distinct solutions. So the answer is 4 to this question, and therefore number 17, that would be D. Square pyramid ABCDE has base ABCD, which measures 3 centimeters on a side, and altitude AE perpendicular to the base, which measures 6 centimeters. Point P lies on BE 1/3 of the way from B to E. Point Q lies on DE 1/3 of the way from D to E. And point R lies on CE 2/3 of the way from C to E. What is the area in square centimeters of triangle PQR? This diagram will help us with this question. Everything is labeled according to the question stem. And now let's label some of these vertices, noticing that this is in the XYZ plane. So A right here, that is going to be the origin for us. So that's 0, 0, 0. And then B is going to be on the x-axis. So that's 3, 0, 0. And C, it looks like that's going to be 3, 3, 0. And D, which is right here, that's going to be just on the y-axis, so 0, 3, 0, since the side of the square is 3. Now let's talk about P, this guy right here. Well, P, they tell me, is 1/3 of the way up from B. As you're going from B to E, it's 1/3. So if I were to draw a line down here, that would actually also, if it were accurately drawn, it would be 1/3 of the way from B to A. And that would mean that that coordinate is 2. So if you write the coordinates for P on the x-axis, it would be 2. Now notice this is a 3D diagram. It doesn't actually even go into the y direction because it's entirely in this plane, the x and z plane. So the y coordinate is 0. And then the z coordinate, same sort of theory here, that it's 1/3 of the way up from B going all the way to E. So if you were to draw a line to the z-axis, it would also be 1/3 of the way up from A going to E. And since that is 6, 1/3 of the way up would be 2. So that's 2. So I hope you understand how I got the coordinates for P. We're going to do the same sort of story for Q. Same sort of dialogue here. Now Q, where is Q? It's right here. That is on this plane, entirely in the ZY plane. So because it's entirely on the ZY plane, Q is lying on DE, as you can see right there. And therefore, the x coordinate would be 0. It's only in the YZ plane. It will have a y coordinate and a z coordinate, but not an x coordinate. X coordinate will be 0, basically. Okay, so same sort of story. It's 1/3 of the way up from D to E. So if we were to draw a line down from Q, that would represent 1/3 of the way back from D as you're going to A. And therefore, that would be 2, since D is 3. So that's the y coordinate there. And then similarly, if you were to draw a line to here, it's 1/3 of the way up from A as you're going to E, and that would mean that's 2. Okay, so now we get to R. R is a little bit trickier, so I'm going to actually draw a line to represent it as it comes down and hits the bottom. So since that hits the bottom, let's just look at the x and y, and then we'll talk about z. So for R, it's coming all the way down, And R is basically 2/3 of the way from C to E. So as you're traveling from C all the way to E, it's 2/3 of the way. So that means this was 2/3 of the way from here to here. So if we were to go there on the y-axis, it would be 2/3 of the way, and therefore that would be 1. So the y-coordinate is 1. X-coordinate, same sort of story. It's going to be 2/3 of the way from B as you're going back to A. So therefore that's also going to be 1. And then now let's talk about Z. Z, you are 2/3 of the way from here to here. So basically it's the equivalent of going 2/3 of the way up from A to E, and 2/3 of the way up of 6 is 4. So that's how you get 4. So I wanted to talk you through that instead of just giving you the coordinates, because some of you may not understand how the coordinates were obtained. Okay, so now that we got that, we can figure out very easily now the distances PQ, PR, and QR. That's just using the distance formula. So it would be 2 minus 0 squared plus 0 minus 2 squared plus 0 squared. And therefore PQ, all under the square root sign. So that's root 8, which is 2 root 2. And then PR, 2 minus 1 squared, which is 1 squared. And then 1 squared plus 2 squared, all under the square root sign. And that is root 6. And then QR, let's see here, 1 squared plus 1 squared plus 2 squared. That's also root 6. Okay, so I don't like that three-dimensional diagram. It's hard for me to understand. But if I were to draw it in terms of 2D, it would basically be that PR and QR are the same. So it's an isosceles triangle. So why make our life difficult? Let's just make it easy. We've got this isosceles triangle, and I'll draw an altitude like that. And the dimensions we have just figured out are root 6, and 2 root 2. And as you know, when you draw the altitude, it chops the base in half only when it's isosceles. So this is root 2, and this is root 2. So we can easily figure out the height using Pythagoras. 8 squared plus root 2 squared, which is 2, is equal to root 6 squared, which is 6. So 8 squared equals 4. H is 2. And then now the area of that triangle is very easy. 1/2 base times height. The base is 2 root 2. The height is 2. And therefore that looks like 2 root 2. So number 18, the answer is C. Rashawn, Sylvia, and Ted play the following game. Each starts with $1. A bell rings every 15 seconds, at which time each of the players who currently has money simultaneously choose one of the other two players independently and at random and gives $1 to that player. What is the probability that after the bell has rung 2,019 times, each player will have $1? You have Rashawn, you have Sylvia, and Ted. Now, Rashawn, he can give to either Sylvia or Ted. And then Sylvia can give to either Rashawn or Ted. And then Ted can give to either Rashawn or Sylvia. Like that. So those are the only possible ways of doing this. So let's label these now. The Rashawn to Sylvia I'll call 1, this I'll call 2, this I'll call 3, this I'll call 4, this I'll call 5, this I'll call 6. So our possible ways of doing this are 1, 3, 5, 1, 3, 6, 1, 4, 5, 1, 4, 6, or you can have 2, 3, 5, 2, 3, 6, 2, 4, 5, or 2, 4, 6, like that. So for each of these, if you go through it, they all start with $1, right? The dollar is the initial amount. So if you start with $1, $1, and $1, and then you go through 1, 3, 5, what happens? I'm just going to do it for a couple. I don't want to go through every single one. I don't want to talk you through every single one because that's going to be painful to listen. But let's just do the first one. 1 is this guy right here. R goes to S. And then 3 is S goes to R. So R goes to S goes to R. So those cancel each other. So that's just going to be 1, 1 like that. He gave that dollar, but then he got the dollar back. And then the last one is this one, T goes to R. So if T goes to R, then that means that this $1 goes to R. So he's going to have 0 and he's going to have 2. So 2, 1, 0 is what happens there. All right, so I'll just do one more, talk you through one more. 1, 3, 6. So 1, 3, and 6. So in the same way, the R goes to S, but then S goes back to R. So those cancel, but then T goes to S this time. So because T goes to S, it'll be 1, 2, 0. And if you go through all these, the result is 1, 1, 1 for that, 0, 2, 1, 2, 0, 1, 1, 1, 1, 1, 0, 2, and 0, 1, 2. So these 8 are the 8 and only possible end results. And if you're practicing, I challenge you to try to find any others. You won't be able to. You'll notice that no matter what scenario you do of these 8 scenarios, you'll end up with one of these 8 possible end results. So we, in our question, want to end up with 1, 1, 1. Well, that's 1, 1, 1, and that's 1, 1, 1. So of the 8 possible ways of ending, 2 end up the way we want. So 2 out of 8 is the probability, which of course in lowest terms is a quarter. And that's it. So number 22, the answer is B. Points A, 6, 13, and B, 12, 11 lie on the circle W in the plane. Suppose that the tangent lines to W at A and B intersect at a point on the x-axis. What is the area of W? This diagram helps to illustrate the question. So let's talk about this. So we have points A and B right here, and they are on a circle. And then the lines that are through that are tangent to the circle, so that basically means that this is a right angle, and this is a right angle. And these are the radii from the center, which is denoted as O. So I'll just write radius right there, R and R. And those tangent points intersect all the way down here at this point T. Now we have to first show how to get that point T. It's labeled, but we have to show how to actually arrive at that. The first thing, of course, is that if you draw a line straight from A to B and then draw a line from that point to there, since we have an understanding that that is equal to that, because any line that's drawn from the same point to a tangent point will be equal, so that is equal to that. This is essentially an isosceles triangle. So if you draw a line down the middle that's perpendicular, which this is basically, it will cut that line in half. So M will be the midpoint of this line. So we can figure out the coordinates of M pretty easily. It's the midpoint of A and B. So it'll be 12 plus 6 over 2, and then 11 plus 13 over 2. So that is going to give a coordinate of 9, 12 for M. Now what I want to do is I want to figure out the slope. I want to figure out the slope of that line, and then that will help me figure out the slope of a line that's perpendicular to it. So the slope of AB we can get from rise over run, of course. So the rise would be 13 minus 11, and the run would be 6 minus 12. So that looks like minus 2 over, or 2 over minus 6 So negative 1/3. So the slope of a perpendicular line, which is basically this guy right here, it would be the negative reciprocal. So the negative reciprocal of negative 1/3 is just 3. So that means the equation of that perpendicular line, which is right here, is going to be y is equal to 3x plus b. And since m is on that line, I can sub that in. So 12 for y and 9 for x. And when I do, I get b is equal to negative 15. So that equation is y is equal to 3x minus 15. Now, that line goes all the way down to the x-axis, so I can figure out that point by substituting y equals 0. When y is 0, 3x minus 15 is 0, and therefore x is equal to 5. So that's how we got that point, 5, 0. Okay, so now we move to the next part of the question. The next part is going to concentrate on this line right here, a to t. And a to t, that slope, again, we can calculate that, rise over run. That's going to be 13 minus 0 over 6 minus 5, which is 13. So the slope of a perpendicular line, which is this one right here, is going to be the negative reciprocal. So the slope of AO will be negative 1 over 13. So the equation of AO would be y is equal to negative 1 over 13x plus some b. And then since this is on that line AO, I can sub in 613. So 13 would be equal to minus 1 over 13 times 6 plus b. And when you solve for b, you get a 175 over 13. So that equation is y is equal to negative 1 over 13 plus 175 over 13. And that is the equation of AO right here. Now, we have AO and we have this line, OT, I guess. And the equations are as follows. This was the equation of AO, line AO. And this one right here was the equation of line OT. And we want the intersection point, because the intersection point is going to be O. So the intersection, you set them equal to each other. Minus 1 over 13 plus 175 over 13. That should be x there. Is equal to 3x minus 15. And when you do this math, let's see here, multiply through by 13, and we get minus x plus 175 is equal to 39x minus 195. And therefore 40x is equal to 370. So x is equal to 37 over 4. Substitute that back into this. And when you do, you get a y value of 51 over 4. So the coordinates of O are 37 over 4, 51 over 4. Okay. Now we can find out R. R, we can use either one. Since we have the coordinates for that, and A, we can use the distance formula to figure out R. So the distance formula, R will be equal to 37 over 4 minus 6. Remember, the other point is 613. So you're just using the distance formula on those 2 points. Squared plus 51 over 4 minus 13 squared, and all under the square root sign. And I'll let you crunch those numbers out, and when you do, you get 1/4 times square root of 170. And then finally, we have to figure out the area of that circle, and that's just pi r squared. So pi times the square root of 170 over 4 all squared, and that is of course going to be 170 over 16 pi, and lowest terms 85 over 8 pi. 85 over 8 pi is C for number 23.